Okay, good evening, good afternoon. Okay, we're going to learn today and continuous turning effect. This is a motto, continuous turning effect. So we learn, we call it, we call it, we call, we learn. Force on current carrying conductor in magnetic field. Force on current carrying conductor in magnetic field. Then we learn turning effect. Turning effect of the coil in magnetic field. Continuous. We learn A and B. A, force on current carrying conductor. We learn force upwards and downwards force. Force upwards and downwards. Force on current carrying conductor. Conductor means straight wire in magnetic field. Then we learn what do you call it? A turning effect. Turning effect of the coil in magnetic field. Turning effect means the force upwards and downwards act simultaneously. Turning effect. Okay, we learn turning effect. Okay, act simultaneously, secara serentak. Today we are going to learn continuous turning effect. The turning effect, you learn this one, we get one turning effect only, up and down, downwards and upwards. Okay, so how to make that as a turning effect continuous turning effect? As a result of the continuous turning effect, we call it rotation. We call it rotation or DC motor effect. Okay, and we are going to learn continuous turning effect. Okay, continuous turning effect. Continuous turning effect. Continuous turning effect, we call this a rotation, or we call it DC motor effect. DC motor. Okay, continuous turning effect. Okay, and as same thing, same method we learn. Okay, this is North Pole. This is South Pole. South Pole and coil. Okay, this is coil. Okay, now we have an extra gadgets or extra fittings. Okay, we got it. This one. Okay, and okay. Battery. Okay, this is the setting of continuous turning effect or DC motor. This is a DC motor. Okay, DC motor, and we call it spring. This is spring, and this one is a carbon brush. And this one is a commutator. This is carbon commutator, either side, both side commutator, both side carbon brush, both side spring, and connect with the battery. and this coil ABCD, coil ABCD. Okay, they want to call coil ABCD, coil same like a B, so C lah. BC. We learn first we learn A, force on current carrying conductor in magnetic field. That means the force, you get force upwards or downwards. Force upwards or downwards. The force on current carrying conductor, the force upwards or downwards. Then we learn B. We learn turning effect of the coil in magnetic field. So the upward force, downwards force, we make it simultaneous, it's just at a certain time. So the force downwards and upwards, so turning effect. So the force downwards and upwards, causing what do you call it, the coil to turn. So the coil will turn only once. But now we are going to learn continuous turning effect. So we are going to learn. Okay, I'll give. Okay, continuous turning effect is we're going to learn this coil ABCD coil, ABCD coil, continuous turning effect, continuous turn like that. So this will this is possible only with commutator and carbon brush. Springs optional. Carbon brush and commutator. Carbon brush and commutator will cause the turning effect of the coil ABCD, the coil turn. So this is what we call it the motor electric fan. For example, fan, the turning fan. The fan turns, or we call blender rotates. Okay, these are rotations. So this is DC motor effect. That one is a fan, and the blender is AC current. This AC motor is different, little bit different. I will tell about this one next class or later. But this one is a commutator and carbon brush. This is a DC motor effect because DC current, battery. Because battery, we call DC motor. They use Fleming's left-hand rule. Okay, left-hand rule. Okay, and this one is okay. This commutator. The commutator is like this. Commutator either side, this side and this side. Okay, the commutator this side and this side, commutator, and touched by carbon brush. Carbon brush, I think I'll some gadgets. Carbon brush. Okay, very good. Carbon brush this side. Carbon brush something like a black in color, something like carbon brush. Both side carbon brush touch. So the carbon brush and commutator. Okay, and carbon brush and commutator. Okay, and I will get for you something. Okay, I will get some instruments. I don't know where I kept it, but it must be there. But I will repeat again to you. This is something like this something like something like a coil, a carbon brush, the commutator either side commutator, and the carbon brush. This one is like this, rotate like this. Okay, rotate like this. Okay, and we supposed to learn the commutator and the carbon brush, how we commutated carbon brush. Okay, and we are going to learn. I don't know where we kept it. I kept it. Okay, I kept it. Okay, I will. Okay, I will. But the instrument, without the instruments, are very difficult to teach. But you must understand commutator and the carbon brush. Commutator and carbon brush. Okay, commutator and the carbon brush. Okay, commutator and the carbon brush. The carbon brush is this. Okay, this is carbon brush. Carbon brush with a spring, battery. This. Okay, the commutator, the carbon brush is a fixed place. Carbon brush either side is a fixed place. But commutator is the one rotating. Commutator is the one rotating in the place. Commutator rotates. Commutator rotates with commutator rotates with coil. So the coil, the end. This one we call end of coil. There's one secret. The end of coil. This is end of coil. End of coil is soldered together with commutator. And end of coil here soldered also. End of coil either side. So the commutator rotates with the coil. Okay, but carbon brush and the spring is a fixed place. So the commutator something like this. Okay, something like this. Okay, the commutator takes over the place. Okay, commutator touch and go. So the commutator. Okay, let's say commutator and the end of the coil, either side, the coil and the end of the coil, the coil ABCD, end of the coil and the end of the coil either side. End of the coil is we call it difficult to explain because it's an instrument. Okay, I'll explain this to you the coming class. Maybe we're going to start the class teaching directly in the class, not the YouTube. Okay, we are going to start the class very soon. So that time I teach you again with this with the instruments, proper instruments. So, but for you to understand, this coil is commutator. Carbon brush and the spring and the battery is fixed value. Okay, commutator touch and go. Okay, this is carbon brush, touch and go. Commutator touch and go. So touch and go. So the commutator and the coil is a link together. Commutator and the coil link by the end of the coil. So the commutator soldered together. So something like this. Okay, this one something like this. Okay, and this is the end of the coil. End of the coil. So this one is a commutator, and the end of the coil is moved like this with carbon brush. Move like this. Okay, and this one is carbon brush and commutator. I will explain this to you, but now try to understand. But I will give you another lessons, and that time you understand better, lah. Okay, and with the proper instruments. Okay, I made some instruments. So to teach this one, I made some instruments. By where I know I kept it 1 year. 1 year ago, I don't know where I kept it. So it must be somewhere. Okay, now we learn this. Okay. North and South Pole. North and South Pole. Okay. A B C D. A B, current going out, going in. Current going in. This current pass through from positive battery, pass through the spring, pass through carbon brush. Current can pass through carbon brush and go through the commutator and the commutator C, like C steps. See here, commutator, the current going in and current coming out. This current coming out, this one. Current coming out, commutator again, carbon brush and the spring, and the current is coming. This one negative. Okay, this current from positive battery, current going to spring, carbon brush, commutator, and end of the coil. End of the coil going to A, B, C, D. Okay, and current coming out. Current coming out towards the carbon brush and commutator. Current coming out through the commutator and carbon brush and the spring, and the current coming like this. Okay, this is current like this. Current like this. Okay, current like this. So we are learn. So current A B C D. Okay, A B South Pole. Okay. I'll show you this one. Okay. And this is North Pole. This is North Pole and this South Pole. This North Pole and South Pole. Current like this. Okay. At North Pole and South Pole, current coming on. Okay, as a battery here, positive battery here, and negative battery. So current going in and out. Current going in and out. Okay. Okay. Sorry. A B C D. Okay. This is positive battery, and negative battery. So current going in AB. This one AB. So AB south near south pole and north pole. South pole and north pole. Okay. Current going in and out. Okay. We're going to use left-hand rule. Okay, left-hand rule. Current going in. That one is current going in. So left-hand rule. So this magnetic field north to south. Current going in and the force acts downwards. Okay, and force downwards like this. And current going out, coming out. CD. Current coming out. So the force acting upwards. The force acting upwards and the force acting downwards. So as a result of that, the one turn. Okay, as a result of it, turning effect. Okay, this force downwards, this force upwards. So turning effect. Okay, this causing, and because I think okay, I put it in the commutator. Assume commutator joined together with the coil. So the commutator, this one is moving like this. The commutator moving like this. Okay, commutator moving like this. Okay, it's because the commutator is joined together or soldered together with the end of the coil. So the coil turns the commutator. The commutator will like this. Okay. Now in this situation, the commutator is not touching the current. It's not touching the current. Battery is like this, commutator like this, up and down. So it's not touching the carbon brush. So the current is not entering. So current is not entering in the coil. Current is not entering in the coil. That means there's one magnetic field only. Permanent magnetic field only. There's no electromagnetic field. In this position, there's no current going into the coil. Current going in. Okay, in this position, current is not going into the coil. So as a result of it, and there's no turning effect, but because of momentum, this move very fast. The momentum caused this coil will fall like this. The coil will fall like this, and the coil fall like this. The commutator come to this position. For example, commutator P. This is commutator P. Let's say commutator P. This commutator Q. Commutator P and commutator Q. So as a result of the force downwards, force upwards, as a result of it, the commutator turn with the coil, because commutator link together, soldered together with the coil. Remember, okay, like this, okay. Commutator P and commutator Q. Commutator P and commutator Q. The mark is one commutator P lah. Okay. As a result of momentum, they fall like this. So the commutator exchange place. Now P has come here and Q come here. But the same, the carbon brush. The carbon brush here. Carbon brush and carbon brush here. Carbon brush never change exchange place, but the commutator exchange place. So now the carbon brush enter current enter. So the current enter through the carbon brush, current enter through it. So positive battery, okay, positive battery. The current enter here and come out. So again, sorry, I suppose to be like this, Suppose be like this, okay? I'll suppose be like this. Because positive battery current is like this, current positive battery like this. Carbon brush here this way. Carbon brush this way, huh? Okay. Now the coil. Okay, I repeat again. Okay, the force acting downwards and the force acting upwards. As a result of it, okay, like this, turn like this. Okay, and because momentum it will fall. Now the commutator exchange place. Commutator P has come here, commutator Q is come here, but carbon brush touch the carbon brush again. Touching the carbon brush again, current will enter. So current will enter the positive, negative battery, the current enter here. Current enter here and current enter here. Enter here. So the same thing, current enter here. So current enter here, same. This current is one way only. Because it's not AC current. Current one way only. So current enter. So is the current enter here. That is current enter, and the force acting downwards, and the current outwards, current out, and force acting upwards. So is again this one. So again this one. Okay, again, force downwards and the force upwards, causing like this. Forcing upwards. So the commutator P is now up there. Commutator Q is down there. So because of moment, now it's not touching carbon brush. So in this position, it's not touching carbon brush, no electromagnetic field. So because of momentum, they fall again. So again, commutator P come back to the original position. Commutator Q is this here. So again, the carbon brush touching. This is a positive battery. This is a positive battery. This is negative battery. Positive battery, so current coming in. So current coming in and going out. Current coming in and going out. So the force current going in, current coming in. So the force acting downwards. The force current coming out, force acting down upwards. So again, this one. Again, this one. Like this. So momentum, because of momentum, fall again. Okay. Again, force like this. Momentum, force like this. Again like this. So the continuous turning effect because of commutator. The commutator exchange place. Every time exchange place, commutator exchange place, current will enter in. Current enter in, there's an electromagnetic field. So the permanent magnetic field here is a permanent magnetic field. This electromagnetic field. So whenever current enter, so in this position, whenever exchange place P Q P, so exchange place current enter one way only, current enter one way. So current enter towards for me towards right and coming out. So the positive battery, this is positive battery. So current coming in and out, coming in and out. So as a result of it, continuous turning effect happens. Or rotations like this. Again, I repeat again to you. Okay, like this. Okay, like this. Okay, like this. Like this. So the coil ABCD and the commutator is a link. So commutator follow the coil, because commutator and the coil this one end of the coil. Commutator and the coil is soldered together. So the carbon brush touch and go. Carbon brush is fixed place in the battery. Carbon brush fixed place. The commutator exchange place. Commutator exchange place because of coil. So this is this continuous turning effect. Okay, and causing it, we call continuous turning effect. Okay, I will give you the definitions, and why we need carbon commutator. Commutator to change direction. Okay, commutator function to change direction of current every after setengah pusingan. If not often, every often, so that the coil rotates in one direction. Okay, this one. Okay, like this. It's anti-clockwise. Coil rotates one direction. So the commutator, the function of commutator to change direction of current every aftens para pusingan, so that the coil rotates in one direction. Okay, and carbon brush. What is the function of carbon brush? Brush? Okay, the carbon brush as a conductor, because they know this commutator. Okay, this is carbon brush. The commutator, this one either side, commutator this side and that side. The commutator move like this, carbon brush. So move like this, and that commutator move like this. P and Q exchange place. P and Q, Q and P, and P and Q and P. So commutator and carbon brush. So the P go to Q and the Q come to P. And the Q go to P and P come to Q. So this rotates. The commutator rotates as per the rotation of the coil. So the commutator and coil is connected together. Okay. So like this. Okay. So we're going to the carbon brush. They have to find one place. Okay. One material which is suitable, because the commutator having friction with the carbon brush. So carbon brush is not metal. This is metal. Commutator is metal. So metal, if they find another metal, copper. For example, copper core and copper commutator is having friction. Is so much friction, so much heat, and so much of what we call sparks will come out. So they have to find out one material which can do two functions. Same first function, the current can go through, current can pass through. Current is a conductor, so carbon brush is a conductor. At the same time, the carbon brush reduce friction, carbon brush reduce friction between carbon brush and the commutator, because commutator is touch and go, always touch and go, having friction. So this is cannot be metal. This is metal, this is metal, this is metal. Cannot have two metals. So metal and metal having friction and sparks. So carbon brush has a dual function. First function, allow the current to flow as a conductor. Second function of the carbon brush, reduce friction. Okay. Battery commutator act as a nature. Okay. Right word is act. Carbon brush function act as a natural lubricator to reduce friction between carbon brush and commutator. So I will explain this one to you again to you, but I will the direct class. We are going to do the class in the class. Okay, in the class maybe we are going to do. Maybe I will give you lessons to you, and maybe physical class. We're going to see each other. Okay. And we do the class. So that time I teach you better, and with the instruments you can understand this better. So meanwhile you do the questions. Question 3. As I gave you homework for you last week, but last week I told you cannot do the question because we have to learn yet you learn. So we have learned motto. Then question 3. Question 3 motto, we learn motto, DC motto, and the empty place here, you must draw the cathode field. Okay, I will teach you this lesson next class. Okay, thank you very much.